Hi, a line has vector equation r equal to 2I add 6j add lambda bracket I minus 3j. State the direction vector and the coordinates of 3 points on the line. Find the position vectors of the points where this line crosses each of the coordinate axes. Well, using this formula, if you look at my previous videos, we can directly read off or state the direction vector d, which is I minus 3j. Next, we need to state 3 points on the line, or the coordinates of 3 points on the line. If we set lambda at 0, then this will be 0, and all we'll have is 2i at 6j. And we know I is the x-axis and j is the y-axis. So our coordinates would be of one of the points would be 2, 6. Just to recap, we have our coordinate system I, j. So I is the x, and j is the y. Another point on the line could be given when we have lambda being 1. I've just chosen to use lambda as 1. You could have chosen other numbers for lambda, and to determine your 3 points on the line. So with lambda equal to 1, now r becomes 2i add 6j add 1 into I minus 3j. Now this evaluates to give us 3i add 3j, which gives us our next set of coordinates, 3, 3. Our third coordinate or point, the set of coordinates or point on the line, is given when lambda is equal to -1. And so the r becomes 2i add 6j minus 1 I minus 3j. And this evaluates to give us I add 9j. This gives us our third coordinate set of coordinates, which is 1, 9. So we have 3 points on the line: 2, 6, 3, 3, and 1, 9. Right, so the line now, like this, the line crosses the x-axis, and that's when y is equal to 0. And that implies that the coefficient of j is 0. So we can write that r, in fact, which is 0, being y equal to 0, we have 0 is equal to 6 add lambda into minus 3. So we've set I to be 0, and now we can calculate what, in fact, sorry, we set j to be 0, so now we can calculate our I value. So this now becomes 6 add, or minus 3 lambda equal to 0. This implies that lambda is equal to 2. So when lambda is equal to 2, we have that r is equal to 2I add 6j add 2 into I minus 3j, which is equal to 4I. Next we have the line crossing the y-axis, and that's when x is equal to 0. So if we set x equal to 0, or our I component, then we can find the j component. So we have that y is equal to 2 add lambda, giving us that 0 is equal to 2 add lambda, which implies that lambda is equal to minus 2. Now with lambda being at negative 2, we can calculate r, which is now 2I add 6j minus 2 into I minus 3j. And that gives us a value of 12j. Thanks for watching. I'm Alistair.